When we're solving equations with rational exponents, we want to start out the same way that we did when we solved radical equations, if you watched that in the previous video. Meaning, before we do any work with exponents, we want to make sure that that part of the equation is isolated. So if there are things besides just the exponent, like pieces outside of there, we want to get rid of those first. So in this case, that 4 we have in front, it's got to go. So we'll start with dividing both sides by 4 to get rid of that, leaving me with x to the 3/2 power is equal to 27. Now at this point, here's what we need to consider. I want to raise both sides to a certain power, and what I want to have happen is I want my exponent to cancel out. And so what I'm thinking is, well, what's the rule for a power raised to a power? And I recall that that rule was to multiply. So in other words, I want to figure out what would I multiply 3/2 by to make it become a 1. And it turns out that what we're going to use, hopefully you've thought of it by this point or remember it from class, we want to raise both sides to the reciprocal power that I'm working with. Multiplying something by its reciprocal will make it cancel out or become a 1. And so my reciprocal of 3/2 is actually 2/3. And so I'm going to raise both sides of this equation to the 2/3 power. As we just mentioned, the rule for raising a power to a power is to multiply. 3/2 times 2/3 cancels out. It becomes just a 1. So I end up with x equals, now be careful, even though we multiplied, we were doing that because we had exponents. 27 is not an exponent, so I'm not doing 27 times 2/3, I'm doing 27 raised to the 2/3. So you can do that on your calculator, or if you recall from the beginning of this unit, a cube root, or a fractional exponent is just a fancy way of writing a root with a power. 3 represents the roots, and then 2 represents the power. So if I want to do this by hand, the cube root of 27 is 3, and then 3 squared gets me 9. So the solution to this should be x equals 9. We should still check these. I think all these rational exponent ones will cancel out, the ones that we see, or that we'll check out. However, it's always a good idea to check it. You know, you can see if you did your problem right or not. Let's take a look at one more example. Once again, before we do any work with our exponents, we want to make sure that that part of the problem is isolated. So if there's anything outside of it, in this case the -1, we want to get rid of that first. So let's start with adding 1 to both sides. I'd have x plus 2 is equal to the x plus 2 to the 3/4 power is equal to 8. Now at this point, I cannot distribute the exponent. There's 2 terms in there. Not that I'd want to. Instead, I want to raise both sides to the reciprocal power to undo that. So I'm going to raise both sides to the 4/3 power. The rule for a power raised to a power is to multiply, and of course multiplying by a reciprocal makes them go away, become a 1. So all that's left is x plus 2 is then equal to 8 raised to the 4/3. Well, once again, if you want to do that by hand, this is the same as the cube root of 8 raised to the 4th power, or you can use a calculator, I suppose. The cube root of 8 is 2, and 2 to the 4th power is 16. Once I solve this linear equation, I end up with an answer of x equal to 14. Once again, it would probably be a good idea to check this just to make sure it works out, and to make sure you didn't make any mistakes along the way.